Today you're going to be introduced to the other side of the number line. Ever since elementary school, you've learned about positive numbers. You've learned about the numbers that start at 0 and go to infinity. Positive numbers are greater than 0 and can be written with or without a positive sign. This is how you would write 3. Positive 3 is equal to 3. Either one is correct. Negative numbers are less than 0 and must have a negative sign to prove they are negative. So this says -4. Two numbers that are the same distance from 0 are called opposites. This is our horizontal number line, and I can choose to put 0 anywhere I choose. If this is 0, then this could be +1 and this could be -1 because they are the same distance from 0. -1 and 1 are opposites. If this was -3, then this would have to be +3. -3 and 3 are opposites. That information is also true if you're using a vertical number line. If this is 0, then this would be 1 and its opposite, -1. This would be 3 and its opposite, -3. Integers are the numbers we've just talked about. Both the positive numbers and the negative numbers, they're opposites. The definition of an integer is the entire set of whole numbers and their opposites. Some integers in real life include a thermometer. This thermometer shows 10 below 0 or -10 degrees. This represents a check that you may have written to LCA for $100. The integer that represents that is -100. This is a picture talking about sea level. 0 is indeed sea level. There are fish that live at different feet below sea level, and some people live so far above sea level that they have to bake differently. This is my box of Bisquick. And on the directions for oven-baked chicken, it says if I live at 3,500 to 6,500 feet above sea level, I should bake 40 minutes longer than I would at sea level. Perhaps you can find something in your cupboard that requires you to bake it differently if you're at sea level or higher than sea level. And here's another example of perhaps a spelling test or something you've done in one of your classes where it says -3. That integer is -3. So, because we know this definition, we should be able to answer questions that look like this. Based on the definition above, which of these are integers? Well, the definition, if we remember, says the entire set of whole numbers. So when I look in this box, I see 3 whole numbers. 9 is a whole number, 1,000 is a whole number, and 0 is a whole number. And their opposites. -6 is the opposite of 6. So -6 is an integer. That leaves us with 3.5, which is 3.5. That is not a whole number, so it is not an integer. And 9/11 is a fraction, not a whole number. In this corner here, you'll see it says this is 0, and he's saying, what about me? And my answer to 0 is this. Good news. You are a whole number, so you are an integer. But you have no classification as to whether you're positive or negative. So a 0 is a whole number, it is an integer, but it is not positive or negative. How do we graph integers? This looks as though you may say that someone graphed 10 and -10. But in order to graph an integer, you must put a closed circle on the number line to show what integers you have graphed. So I may ask you, what is graphed at point A? And your answer would be 30. What is graphed at point D? -40. shows a vertical number line that would allow you to graph any number and its opposite. And remember that opposites are called opposites because they are the same distance from 0. Comparing integers. Now that we know how to graph them, we can use that skill to compare using less than, greater than, or equal to signs. -2 and 4. If I graph -2 and I graph 4, the number line allows me to see that -2 is less than 4. If I graph -3 and I graph -5, the number line allows me to see that -3 is greater than -5. Putting these numbers in order from least to greatest could be as simple as plotting them on our number line. -6, 12, 9, which is not necessarily listed on our number line because we're counting by 2's, but we know that we could plot in between 8 and 10, and that would represent 9. 0 and -2. And because we've plotted them on our number line, we can now write them in order from smallest to biggest, from least to greatest. -6, -2, 0, 9, and 12. When comparing integers, it may be helpful to remember that left is least. The number furthest on the left is the smallest number. At this point, I'd like for you to push pause and solve these 3 problems. All right, let's solve these together and see how you did. If you have to graph each integer on the same number line and write a real-life context for each, your number line may have looked something like this. And you graphed -4, and you graphed 7. Then you wrote a real-life context for each. Maybe you said that you owe someone $4. Maybe you used 4 feet below sea level or 4 degrees below 0. Maybe you were playing a game and lost 4 points. 7 could be written because your sister is 7 years old, or you're 7 feet above sea level, or 7 degrees, or you scored 7 points in a game, or got 7 bonus points on a test. On another number line, it says to graph 3 and its opposite. So your number line, and hopefully you didn't just do this, but you did indeed graph 3 and its opposite with a closed circle on the hash mark. To compare these integers, -3 is further left on the number line, so 3 is less than 1. -9 is the smallest of these 2 numbers, so it would get 1 dot, and -5 would get 2 dots because it's larger of the 2, and I would connect the dots. To make the math sentence, -9 is less than -5. 4 is larger than 2. Connecting the dots creates the math sentence, 4 is greater than 2. Have these in your journal and be ready for class tomorrow to show what you know about integers.